What's up, everybody? Today, me and Josiah, Brandon, and Sean are going to all teach you about the best subject ever, forensic engineering. I'm Jared Green. I'm going to tell you what is forensic engineering and what does the field involve. Forensic engineering is the investigation of materials and structures or components that are unsuccessful or do not run or function as planned, and they end up causing people or structures injured. You don't want to be product liable, and what that means is concerning who is responsible for defective or dangerous products. As the field of engineering has evolved over time, so has the field of forensic engineering. Early examples include investigation of bridge failures, houses being broken down, lots of big businesses that just break it down and we search to see what happened, what failed in it. The field of forensic engineering also deals with accidents in operation of vehicles or machinery. Forensic engineering investigations is applied most commonly in civil law cases, although it may be of use in criminal law cases. Purpose of forensic engineering investigation is to locate cause or causes of failure in the machinery or a broken down building. A big, vital part to the field of forensic engineering is the process of investigating and collecting data related to the materials. In forensic engineering, the products, structures, or components that failed, that is what we search. That's what we inspect for, collect the evidence that is broken down or failed. We do measurements, and we develop the models that we got out of all that evidence. And then, at the end of the day, we assist the court in determining the facts of that accident or failure that happened. In forensic engineering, there are two big roles. The first role is the detective role. The detective role, with the help of law enforcement, they look for clues about what happened and evidence to achieve certainty about what exactly occurred and when it happened. For example, a car accident. If a car hits another car, they're both going a certain amount of speed. That's what we have to find out. We have to find the certain amount of speed that the car hits, the angle of impact if he got hit in the front, back, or side, and the lack of a seatbelt. We also look at that, find out what happened to the car and whose fault it is and how big of an accident is it. The second big role is the engineering role. The engineering role investigates roles of mechanical failures. For example, like a crane. When a big crane fails or someone's not operating it right and it just screws everything up, it crashes, like that's $1 million right there. And we investigate that, like how did a crane collapse or how did the building collapse? That's the mechanical failures. And at the end of the day, all the info obtained can be used in court cases and also often personal injury and product liability. For education and training for forensic engineering, it's not too complicated. That education is at least a 4-year degree in engineering or majoring in a relevant subfield like electrical, mechanical, civil, chemical, engineering, all that. There's no specific degree for forensic engineering. Also, common courses like Intro to Engineering, Advanced Mathematics, Computer Applications, distributed systems and fields. Also, there's obviously skills and training required for forensic engineering. The skills are obviously a firm understanding of the scientific method. You need a good attention to detail and critical thinking. Also, good mathematical skills for like angles, like earlier the car crash, like see where point of impact is and everything. Resourcefulness and time management. Obviously, you don't want to be stuck on the same thing for a long time. Also, active listening and social, like gathering, like where you talk to people and test it in labs together and communicate with others. And just the other one is the ability to communicate clearly, both verbally and in writing for purposes of gathering info and reporting findings.
So let's talk about job structure now. There are full-time and part-time positions available, but the majority of what I turned up online was for full-time hours. Salary does depend on many factors, but the average salary in the U.S. is just over $80,000 a year, with a range of between $59,000 and $123,000 a year. The highest paying states are California and D.C., with an average of about $91,000 to $93,000 annually. Factors include technical knowledge, job location, management skills, experience, and of course academic background, with the biggest factor being career length. Basically, the longer you work, the more you make every year. Most companies offer medical and dental coverage, and most of them also offer vision coverage. Forensic engineers can work for city, state, or federal governments, or one of many privately owned companies. The majority of what I turned up online in employment websites is for fire safety engineers, structural engineers, and forensic mechanical engineers. Another interesting position is that of a computer forensic engineer, and there is actually a current position open for the Facebook security team, and his job would be to analyze and manage internal investigations while also implementing new decisions for suspicious activities. Or you could always be a digital forensic engineer for the CIA, where you would prevent and track cyber attacks. Another position I found was that of a forensic electrical engineer who would investigate and analyze the origin of failures, damages, or defects in electrical fields within industrial, residential, and commercial sites. Employers tend to prefer applicants who have prior experience in civil, structural, or mechanical engineering, and another common requirement is that you must be able to complete all assignments within given deadlines in accordance with company guidelines and policies. They must also be willing to testify in court and have good communication skills in order to present well-written forensic reports.
In the past, some of the methods used are the careful analysis of the service record of the component, the review of the loads carried, record of the temperature suffered, analysis of the microstructure of the material used, assessment of witness evidence. This was usually carried out by optical microscopy, X-ray diffraction, and chemical analysis. All of these are still required, but forensic engineering has been aided by the introduction of certain key concepts and methods. As of current, the methods that are used are fracture mechanics, which is the analysis of loads applied to bodies containing cracks. Scanning electron microscopes that enables fractured surfaces to be analyzed at magnifications of thousands to determine modes of failure, as well as the mechanical composition of key components of the microstructure. Finite element analysis, which assists in the determination of numerical mathematics of stresses the temperatures put on all positions within a structure. Computational fluid dynamics, which uses numerical mathematics to determine effects of fluids, gases, or solids on components or structures. And impact dynamics, that is the use of numerical and analytical codes and models to determine the behavior of structure when hit by fast-moving projectiles. A few of the other tools used are tensile machine, which is capable of loading up to 120,000 pounds in tension or compression. Survey equipment utilizes both point cloud scanning and point-to-point survey techniques. Vehicle event data records on both passenger and commercial vehicles, and a full metallurgical lab. Some of the tests conducted in lab are metallographic examination of steel parts to determine heat-treated condition, hardness test to evaluate material properties, micro-hardness test to evaluate weld quality, dye pertinent testing to check for cracks, electron microscopy of fractured surfaces, temperature measurement pertaining to thermostatic controls, bend test on metal, coating thickness of painted layers of metal parts, tensile properties of metal and plastic parts, microscopic analysis of magnesium alloy particles, iron impregnated magnesium powder, calcium carbonate sphere analysis, destructive and non-destructive testing, use of strain gauges to evaluate stress conditions, chemical analysis of corrosion product, and comparison testing. So for example, when a product fails for no actual reason, a energy dispersive X-ray spectroscopy is performed and the microscope can reveal the existence of hostile chemicals that left traces on the brake or nearby surfaces. Evidence is extremely essential in the investigation of forensic engineers. More specifically, trace evidence, which is an important element in recreating the structure of events in an accident. Stuff like tire burn marks on a road surface can enable vehicle speeds to be estimated, when the brakes were used, and so on. Ladder feet frequently leave a trace of movement of the ladder throughout a fall, and may possibly show how the accident happened. In 1999, Miller Park Baseball Stadium was under construction in Milwaukee, Wisconsin. While installing the retractable roof, Big Blue, the crane, collapsed with over 450 tons on the hook. The incident resulted in the deaths of 3 ironworkers, Jeffrey Wisher, William DeGrade, and Jerome Starr, who were observing the lift when hit by the falling crane. A camera crew was recording the construction that day and captured the collapse as it happened.
Coming down now. We have to train iron workers. What's going on here? Okay, watch it, watch it! Shit! 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 I got on. Shit!
Typically, the first thing to analyze in a situation like this is whether or not the crane was trying to lift a load beyond its capacity. In this case, the crane had a rated load of over 1,000 tons at the time of the failure, which was significantly higher than what it was carrying. Based on the crane's lift rating, previous track record, and observation of the video of the collapse, it was concluded that the weight of the lift alone was not the cause of the failure. One theory suggests the ground could not support the weight of the load the crane was attempting to carry. 2 of the workers running the lift at the time of the failure saw one of the crane's tracks sinking just prior to the accident. This potential factor is also noted in OSHA's final report. Another indicator that this might have been a mitigating factor was the discovery of a broken 12-inch water main 6 feet below and 12 feet away from the base of the crane, which was not believed to have been broken prior to the crane's failure. The leading theory had to do with the high wind velocity at the time of the accident. 2 veteran crane accident investigators agreed that large structures should not be lifted in winds exceeding 20 miles an hour. Wind speed taken at various sites in the area during the time of the failure ranged from 23 to 35 miles an hour. When considering the fact that it's even hard for a person to stand still at ground level during these wind speeds, it should be clear that attempting to balance a large suspended load would probably not be a very good idea. Winds at higher elevations were so noticeable that day that a group of iron workers had left the job site at around noon over concern for their personal safety. 2 monitoring devices designed to trigger an alarm at excessive wind speeds were later found to have dead batteries. Ultimately, the OSHA investigation was limited in scope due to time constraints, so they ended up focusing on work safety violations as opposed to being able to determine the root cause or causes of the crane failure. So unfortunately, we're just left with proposed theories and potential factors. The final report did note that wind was a contributing factor.
As a result of the collapse, 3 firms were fined a total amount of $500,000. The widows of the workers, Marjorie DeGrade, Ramona Duld-Starr, and Patricia Wisher, settled a lawsuit against Mitsubishi Heavy Industries of America, the company responsible for installing the retractable roof on the stadium, for $57 million. In 2001, a bronze statue was installed in front of Miller Park to honor the 3 iron workers.